Hi everyone, this video will be a last-minute cram session where I'll be covering key details from Precalculus Unit 4. So if you have a midterm or test coming up, I hope this video helps, and let's get straight into it. So section 4-1 is the derivative and tangent line problem. So for this section, there's really only one type of problem that you're going to encounter. And so I have an example here, and I'm trying to find the slope of the tangent line to the graph of the function at a given point. So this is our given point. That is our point of tangency. And what a point of tangency is, it sounds super complicated, but it's just a point that you're using to find the tangent equation. So for point of tangency, always use the original equation, not the derivative. And then the second thing we need to find is m tan. So what m tan is, it's the instantaneous rate of change of the function at a point. So the way you find m tan is to take the derivative of the function. So here I'm going to take derivative of g of x. So g prime of x is equal to 2x. So this equation right here, we're going to plug in our x value of our point of tangency to find the slope at that point. So g prime of 2 is 4. And so 4 is our m tan value. Now we have our slope and we have our point of tangency, and we can use that to make our equation. So our equation is always going to be in the form of y minus y1 is equal to m times x minus x1. That's our point slope form. So y minus negative 5 is equal to 4 times x minus 2. Y plus 5 equal to 4 times x minus 2. On the test, you want to leave it like this because you don't have that much time. Don't bother even simplifying everything out. Another concept you need to know for this section is horizontal and vertical tangent lines. Remember, a horizontal tangent line occurs when the derivative of the function is 0. So if you're trying to find a horizontal tangent line, or the point where a horizontal tangent line occurs, when you have a derivative of a function, you're going to set that equal to 0. And what that means is that if you have a rational function or any type of function, that numerator, you're going to solve for what makes that 0. So here, if x is equal to 1, then that numerator is equal to 0. So that's where the horizontal tangent line occurs. Now, a vertical tangent line is very similar, but it occurs where the derivative of the function is undefined. So usually, this comes from a derivative that is a rational function, like we have here. So here, the denominator, we know that whatever makes the denominator 0, that's going to make the entire function undefined. So for a vertical tangent, we know that if x is equal to negative 1 in this case, that's going to make the denominator 0, and so x is equal to negative 1 is the x coordinate of the point where a vertical tangent line occurs. Okay, another common problem that you'll see is lines that pass through a point. This question asks you to find the tangent line of a graph that passes through an indicated point. It gives you an indicated point, but it doesn't give you a point of tangency. So to find the point of tangency, let's look at 61. The point of tangency occurs here, right? That's where the tangent line occurs. But we aren't given the point of tangency. So to find that, we have to find the slope of this line right here. Okay, so to find the slope of a line where we're given 2 points. So here we're given 2, 5. Let's label that as a, f of a. And then this point, we don't know yet, but we know that it's going to be a point of the function f of x. So the point we can label as x, f of x. Now this is a secant line, it's a linear line, so we're going to use rise over run to find that slope. So rise over run, it's the slope formula that you learned in like 2nd grade. It's like y2 minus y1 over x2 minus x1. And so here, instead of that formula, you're going to plug in these points as your x1, y1, and x2, y2. Okay, so your first step is going to find the derivative of the function. Then you're going to find the point of tangency by setting m secant equal to m tan. So you're going to set the slope of this line equal to your derivative function. So the slope of that line is f of x minus f of a all over x minus a. You want to memorize this formula right here. And that's just rise over run. It's very simple. You're going to set that equal to your f prime of x. And then whatever you solve here, whatever x value that you get, you're going to plug that into the derivative to find the slope value. It's a numerical value that you're finding here. And then you're going to also plug in the x value into f of x, your original equation, to find the coordinates of point of tangency. So after you do these first two steps, the third step is what you've done all along. It's the same thing that we did earlier. And then you use the point slope formula to get your equation of the tangent line. Okay, so keyword, if you see horizontal tangent in the problem, you're going to set the derivative equal to 0. Whatever value you get, that's the x-coordinate of the point where a horizontal tangent line occurs. If you see vertical tangent, you're going to find where the derivative is undefined. So if it's a fraction, find what makes the denominator 0. If it's a log function, find what makes the argument 0. If it's a square root function, find what makes the inside expression less than 0 or negative. And then to find the equation of a tangent line that passes through a point, remember the m secant function or rise over run. You're going to set m secant equal to m tan, which is the derivative of the function that you're given. Okay, chain rule. So chain rule is just another way of taking a derivative. And so if you have an expression inside of an expression, you must use chain rule. So ignore the inner expression and take the derivative of the outer expression first, and then multiply that entire thing by the derivative of the inner. So fun fact, you don't realize it, but you do chain rule with every derivative that you take. So if you take the derivative of x squared, then you do 2x times the derivative of the inner function x, which is 1. And so that's 2x. So you don't realize it, but you're doing chain rule literally every single day. Section 4-5 is implicit differentiation. So implicit differentiation is just an application of chain rule. Most problems, if not all, will ask to derive with respect to x. And what that looks like is the problem will say, find y prime or find dy dx. Y prime and dy dx are essentially the same thing, so you can use those interchangeably. So for this example, it says find y prime. So you're finding the derivative of your function with respect to x. And so what that means is that when you're deriving this equation right here, whatever variable does not match with x, whatever variable is basically not x, you're going to multiply it by its derivative again. And so what that looks like is the derivative of 2x is 2, plus, then you're going to use product rule. So I'm going to do x squared first. The derivative of x squared is 2x, and then you're multiplying by y, plus x squared times, then the derivative of y is 1, right? But y does not match up with x. You're doing it with respect to x, but y is not x. And so you're going to multiply it by y prime, or dy dx. And then 3 is just equal to 0 when you derive it. And then from here, you're just going to expand this and just isolate y prime, and whatever you get for y prime, that's going to be your answer. Now, if a problem asks you to find the second derivative, which looks like this, make a mental note to yourself before you solve the problem to plug in y prime or dy dx. Whenever I do these types of problems, I always get so confused at the end because I'm like, what's the goal of this problem again? But remember that when you're finding the second derivative, you're going to end up with an expression that has y prime in it. But you can't just leave y prime in there. You're going to need to find y prime, which you should have done already. And then whatever expression you got from that, you're going to plug it into y double prime. And I'm not going to solve this out, but just make a mental note to yourself that if your end goal is to find y double prime, it has to be in terms of x and y only. It can't have y prime in the expression. So you gotta plug in y prime to just make it all in terms of x and y. Okay, last section 4-6 is related rates. So related rates, if you identify a pattern, you can solve literally any related rates problem. Usually the last sentence in the problem is going to ask you to find something, and that's how you know what rate you're ultimately solving for. So you want to refer to the last sentence in the problem for what you're solving. Usually it's going to be like dh dt, at what rate is the height falling, dv dt, at what rate is the amount of water changing, or stuff like that. You want to make sure that you pinpoint exactly what you're solving for at the beginning. And then another thing is you must memorize the basic formulas. So you're going to probably use Pythagorean theorem for triangles. You're going to use volume and surface area. Surface area, maybe not, but definitely volume for cylinder, cone, spheres. Usually those three. Another thing you want to know is that if a rate is decreasing, so the problem says the level of water is falling at a rate or a distance is decreasing at a rate, you must put a negative in front of the rate. So remember negatives. Don't be afraid to do like negative dh dt. If you're certain that the problem is saying that the rate is decreasing, make sure you put a negative on there. If you need additional help on related rates, I made a separate video on my channel, so go check that out if you need additional help. Okay, that's it. I hope everyone has a good test, and make sure to get plenty of sleep the night before, and I'll see you guys in my next video. Bye!